Let's go slowly code 2326. Spiral matrix for this question, it gives us two integer m and n. Let's compose a matrix which has row counts to be m and column counts to be n. And it gives us a linked list. And let's to fill the linked list value to the matrix. And the linked list, we go node by node. And when we fill the matrix, we just use a spiral way to rotate. It says that the linked list has nodes less than n multiplied by n. And if there are, when we finish the linked list, if there are still some cells not being filled, we use -1 to fill in the matrix. And it says that the linked list has length smaller or equal to m multiplied by n. So if we'll say if it is m multiplied by n, it will always fill the matrix out. It is a mathematical improvement. And for us, and we just simulated a question. Initially, we stand at zero, cell 0, 0, and that direction is going to the right. So we can create that direction array, D row and D column. And when we go to the edge, for example, when we go to the right, we find if the next cell is going out, then we change the direction, then go down. And when we go down, if we find the next cell, we'll go to the bottom, for example, M or some of the rows we already filled the data. Then we change the direction to go left. And when we go left, if we go out of bound or we go to the left edge, and we change the direction to go up until we fill out of the matrix. So intuitively, what's thinking about is that we can use 4 variables, which is up, right, and for the top edge, top limit, or bottom and the left and the right, right? So if we are on the right direction, if we are hitting right, then we change the direction. But the thing is that for this question, right? So we just have a D row and a D column array, and trying to see the next row and next column. If the next row and the next column is going to go out of bounds, or the next row or next count, it already being filled the data, fill any numbers, right? So you see that the linked list has always a positive number. So means, for example, it has a positive number. That means we should change those kind of the next cell is the one we already being filled, right? In this kind of case, we need to change direction. So we just simulated the problem in the right code. So we know we need a 4 direction array, right? So we'll say private final static int for D row. So also D column. So the first is the initiality is to the right, right? Right, the row will change, column will add 1, right? And if we change direction, we are going to go down, right? So the row will +1, the column will change. And then if we change direction, the row will not change, but the column will change -1. And then if we change direction, the row will go up, right? Column is changed to there. So the result is two-dimensional right? Result equals mu int m n. Initially, let's set fill the data as -1 because so that we don't need to worry about the one which we do not we didn't fill, right? Yeah, -1. So we just simulate the steps. So we know initially the row is at 0, column is at 0, right? And we have direction array. Initially, we are going to the right. So what we do is while this kind of linked list is not null, right? Then equal to null. So we are going to have current equal current dot next. So we'll see this kind of row result row column equals current dot value, right? So what is current? We'll say let's have list node current equals head. So instead of use upper limit, down limit, left limit, right limit, we can just write int new row equals row plus plus d row er and int new column equals column plus d column er, right? So let's say if new row smaller than 0 or new row greater equal to m or new column smaller than 0 or new column greater equal to n, right? And another case is that this is on the edge, this kind of run, right? This kind of run. And the other one is that in the inner, if we find someone which already being filled, right? For example, this 5, if we got, we'll see it's 3, not -1, means we already update this kind of cell. So we'll say, oh, result new row new column doesn't equal to -1, right? In this case, we need to change direction. So direction equals direction +1 mod 4, right? And then if we change the direction, right? For this question, it's impossible that we change the direction multiple times because we can see if we have only one row left, right? And if we are at for example here, right? Then we can come here, come down, and go back, right? So it's impossible that it's on this kind of edge finish and down is finishing as well, right? So we just need to use one if should be fine, and we'll have row plus equal to 0 dir and the column plus equal d column dir, right? And in the end, we just return result. doing like this, the time complexity will be n multiplied by n, right? Space will also have this kind of matrix and multiplied by n. Let's write this one as Python code as well. So Python code will be very similar. We need to have a D row array, right? Equals this is right, down, left, and up. And we'll have the column equals this is the right column will plus one, and down column will not change, and the left and the right, and up, right. So we'll have row initial row column equals 0, 0, and we need dir, right? dir equals 0. Let's say let's call it the direction, right? Equals 0. So initially this as 0 in direction as 0, right? So we need a current equals head. So I say why this current doesn't equal to none, right? Then we'll have we need to have result. Result equals so we fill this one as -1 multiply n for in range m. So we'll have result row column equals current plot value, and we have a new row equals row plus the row GRR D, right? And the new column equals column plus the column D. So let's say if new row smaller than 0, or new row greater equal to m, or new column smaller than 0, or new column greater equal to n, or result new row new column down equal to -1, right? In this case, we need to change direction. E equals E plus 1 multiple, right? And then after change direction, we have row should plus equal to D row D, and the column plus equal to D column D, and we'll have current equals current of the next. In the end, we just return result.